So I will now give the microphone to Professor Robin Dennell, who is going to speak more widely about the question of the first presence of hominins outside of Africa.
First, I'd like to thank Yves Capin for inviting me to this symposium. It's been a pleasure and a privilege to be here. And if we get this thing working, lower one, okay. Before I begin, I should also acknowledge my Chinese colleagues, without whom this work would not be possible. That's Jiao Zhu in particular from Guangzhou, Huangwei Wen from Beijing, and the rest of the team from Guangzhou, particularly Wu Fu and Xi Chufan, who are the basis of the field team. Now, as way of background, since 2000, the earliest generally accepted site outside Africa has been Dmanisi in the Caucasus, shown here, top right, the excavation, and the Homo erectus reconstructions at the bottom. The date is between 1.75 and 1.85 million years ago. It's an amazing site that produced also a highly variable population with 5 skulls, attributed either to Homo georgicus or a simple form of Homo erectus, along with postcranial data on its locomotion and manual dexterity. It's showing that it's socially complex in that this individual was fed for several years even though it had no teeth. We know about the faunal preservation is staggering at Dmanisi. You're probably looking here at a carnivore locality where the hominins are the dinner rather than the diner. We know there's a simple stone tool industry at Dmanisi as well. So that's been the baseline for Out of Africa 1 in Asia since 2000. Now at this point I'll transfer you 3,000 or 4,000 kilometers east into central China, and here we have to acknowledge a remarkable Chinese geologist called Lloyd Dongsheng, who lived a very long time, and his main work was in central China on the area known as the Loess Plateau. Now the Loess Plateau is about the same size as France. It's very, very large indeed, and it's situated between the Qingling Mountains in the south, which divides north from South China. So it's temperate in the north and subtropical in the south. The soils are different, the fauna is different, the crops are different, so it's a very basic division. And to the north of the Loess Plateau, we grade into deserts like the Mu'us and the Tenga and the Gobi and head north towards Mongolia. So the Loess Plateau is primarily semi-arid in the south and increasingly arid as one goes north. Here it is from Google Earth. You can see within the red square, that's the Loess Plateau to the north, increasingly arid deserts, and the Qingling Mountains down to the south. Beijing is in the top right-hand corner. Now, as you get closer to the Loess Plateau, you can see it's deeply dissected. There are as many gullies in the Loess Plateau as there are caves in South Africa. It's very fertile soil, but very soft and very easily eroded. And so it's ideal for geological exploration. The Loess Plateau is basically and essentially the world's biggest heap of wind-blown dust. And that's dust which is brought down often very dramatically from the north by the winter monsoon winds, sometimes a major threat to human health and life, but normally on a much gentler scale. You have sometimes great violent dust storms in North China and a major hazard, as I say, to human health. Dust deposition has been on a massive scale over the last 22 million years in China, and for the last 2.5 million years, the main deposit has been loess, a yellow wind-blown loess, mainly silt with some clay particles as well. In the northwest part of the Loess Plateau, nearest the source of wind, the loess is 300 meters thick. Here in the center at Luotuan, the type section, is 175 meters thick. To the south, where I'll be taking you later, it's around 70 to 100 meters thick. So by European standards, these are very, very large, long sections. Now, in the 1960s and 70s, Lloyd Dongsheng was the first to explore the stratigraphy of the Loess Plateau. And he showed two things. The first was that there was a sequence in the last 2.5 million years, 33 episodes of Loess deposition and 32 episodes when soils developed under moisture and warmer conditions. So he showed first there was a chronology, and that it could be dated by paleomagnetism in particular, and the age of each of those Loess and soil units could be estimated with a great deal of accuracy, down indeed to 2 decimal places. And that is fairly unique in the Northern Hemisphere. He also showed that it was a climatic signal, that the grain size was an indicator of wind strength. So the stronger the wind, the coarser the grain of the Loess that was deposited. So grain size is a proxy indicator of cold, dry conditions. And in warmer, moist intervals, the equivalent of interglacials, there's greater biological activity, more oxidation, and therefore the magnetic susceptibility is a proxy indicator of warm, wet conditions. So we have here what is on land the longest, most continuous and most detailed record of climatic change over the last 2.5 million years. And furthermore, each of those episodes can be dated, as I say, to 2 decimal places and linked to the marine deep sea record. So it is a phenomenal archive of climatic change. And since Lloyd Dongsheng's work, his first and second generation students have mapped the Loess Plateau on an industrial scale. And what is remarkable with the Loess Plateau is that geologically it's very simple indeed. You can trace the same horizons from east to west across the Loess Plateau for 800 kilometers and from north to south for another 500 kilometers. So no matter where you are on the Loess Plateau, you still see the same sequence and the same marker horizons. So without going into details, you have there Luotuan is the type section on the left, and then other major sections like Shifeng, Baoji, Duanjiapo, and many others. And on the right, there's a new section, which I'll show you from a place called Lantien, Shangqian. Now, in terms of the background to this work archaeologically, in North China, the earliest sites to date come from the Nihaoan Basin, which lies on the northeast edge of the Loess Plateau near Beijing. It's a paleo lake system which dried out around 270,000 years ago, and the Loess caps is the uppermost unit from the last glacial cycle. But before that, these deposits are mainly lacustrine, either lake deposits or lake foreshore deposits. And Chinese researchers excavated this site called Maojiaoyingou 3, published in Nature in 2004, and that has an estimated age of 1.66 million. And the age is estimated between 2 anchor points of the Olduvai subchron and the Brunnes-Matuyama boundary, and the Yaramilo subchron at 0.9. By estimating the average rate of sedimentation, the age of Maojiaoyingou 3 is placed at 1.66 million. I would be a little bit elastic with that date because you're having to estimate the age from an average rate of sedimentation over a very long period of time. So there are problems of faulting and different rates of sedimentation and so forth. But for the moment, that is the anchor, the baseline of hominin presence in North China. There are no hominin remains from the Nihawan Basin, so we have no idea who made those artifacts. But we now go to Lantien County, to a locality called Gongwangling. You can see there in the main photograph the Qingling Mountains to the south, rising to about 2,000 or 3,000 meters, the Loess Plateau in the foreground, and there are two sections shown by red arrows. Gongwangling is the further south, Shangsheng to the north. Back in 1964, that skull was found at a place called Gongwangling, and at the time it was dated with very, very limited sampling of paleomagnetic samples, and placed in Loess 15 at around 1.1 million years ago. The correlation of that skull with Loess 15 was very strange, because Loess 15 is a very, very thick, silty Loess unit, denoting extremely cold and arid conditions, and not quite the ideal habitat for a subtropical Homo erectus. So there have been consistent doubts about its stratigraphic placement. What my Chinese colleagues did was to reinvestigate the original section, which amazingly the Chinese preserved in an enormous building. So it's open to scientists to re-inspect and the general public to look at under guided tours. The Lantien Homo erectus has its own little temple outside. But what my Chinese colleagues did was they discovered there is a major stratigraphic break in that sequence at Gongwangling, below Loess 15, and the Homo erectus skull was actually found in soil 23. Now that's placed at 1.63 million years ago, not 1.1, so it's 500,000 years older than first estimated. So it's now more or less the same age as those artifacts from Maozhou and Go in the Nihawan Basin at 1.66 million years. And the redating of the Lantien Gongwangling skull now means that it's the second oldest site outside Africa with cranial remains. It's a small-brained individual, and it fits actually quite neatly with the Dominese population, with a cranial capacity of 775 cc's, which is within the range of the larger Dominese specimens. So it looks as though a Dominese-type Homo erectus, small-brained, small-bodied, bipedal, did disperse as far east as North China by at least 1.66 million years ago. So that's the result of its redating. It's now slightly older probably than Sanggaran in Java, slightly younger than Dominese, and that was published in 2015 in the Journal of Human Evolution by Jiao, myself, and other colleagues. Now, in the course of that work, when the Chinese were reinvestigating the Gongwangling section and other sections in that area, they started to find stone tools, and at that point they invited me to join their team. The people in particular to acknowledge, as I say, are Jiao Zhu, Huangwei Wen, Wu Yi, and Xi Chifan. They, I think, have done a splendid job. I'm happy to report on their behalf that the Chinese Ministry of Science and Technology nominated this work as one of the top 10 science achievements in China in 2018. Now, what we have at Shangcheng is a 70-meter section of Loess, which, if you like Loess sections, is stunningly beautiful. Loess 15 is that thick, white, silty layer I mentioned earlier, denoting very cold, arid conditions, and that's the obvious marker horizon. There's one called Soil 5 at the top, which is tripartite and around 500,000 years old. And Loess 25 towards the lower part of that photograph is another white, silty layer denoting cold conditions. And those form convenient marker horizons. You can see the sections layered like a cake. Those slightly redder layers denote the paleosols, the interglacials, or the equivalents. And the yellow denotes colder, drier conditions. So if you're in that sort of section, all you have to do is find your marker horizon and count down and then up from the underlying marker horizon, and then you know where you are in that amazing Loess Paleosol sequence identified for the first time by Lloyd Dongsheng so many years ago. Loess 28, I'll mention later. That age of that is beyond 2 million years. At the moment, we can't go further down because we're at the base of gully and it's obscured by, well, we've run out of section or it's covered by cropland. The Chinese took 5 main sections around Shangqian village and a 6th critical one called KW on the other side of the hill. And in true style, Chinese created their composite section. You can see that on the right. It extends from 2.1 million from soil 28 right up to the top, soil 1. Sampling at 10 centimeter intervals on average for paleomagnetic purposes. I think they took around 700 paired samples for dating purposes. So the age is very precisely known. And you can see on the right-hand side of that figure of the Shangqian composite section, the paleomagnetic sequence. The bulge to the right at the base is the Olduvai event, and then you have the Brunez Matayama boundary at the top and the Yarrow Meadow in between. And the reunion event is also there at the base. So that provides the anchor points for the chronology. In the field, the sections are steep, which is ideal for sampling for paleomagnetism, and it's ideal if you find anything in context, because you know it cannot have got lodged there by accident had it fallen down slope, because the gradient's simply too steep. Anything at the top will go straight down to the bottom. Working on the higher parts of those sections can be delicate. You have to be careful. Shown on the right, the foothold or heel hold. But it is possible then to cut your way down for paleomagnetic sampling. And what you need to do in the field is work your way along each of those units if you can, cleaning up as you go in search of artifacts. The work's slow and you have to be very methodical. Initially, the Chinese working in soil 22 started to find artifacts made of quartzite. I should mention, key point with the Loess Plateau is that it is a stone-free landscape. It's dust and nothing else. Out in the Loess Plateau, that's all you have. You have no conglomerates, no colluvial deposits, no stream bed deposits to complicate things. There's no stone whatsoever. The stone is in the Qingling Mountains or in the streams running immediately off it. So I think in places like Shangqian, you're in the Goldilocks zone, that you're far enough out in the Loess Plateau to have the entire sequence, but near enough for there to be a source of stone for hominids to transport out into the Loess Plateau in the course of their daily or seasonal activities. All the artifacts that we have found have been fresh. None of it's rolled. There's no possibility of water transport. It's all in either Loess or a paleosol unit. And it all shows clear fracture patterns. That's from soil 22. Now, I'll not show you everything in detail. It's in the Nature paper published in July last year. But I'll show you some of the horizons to get across to you the methodology. No, it doesn't work. The main photograph at the top shows the gradient. It's a fairly steep slope. There is a thin layer of slope wash where the vegetation is, and a thin crust which is around 3 to 6 centimeters thick. Very loose, very easily recognized. Once you get rid of that, you're into intact loess or paleosol. So what we were doing was when the Chinese took the paleomag sample, they would break it out laterally to see if there was anything else. And in that photograph, there's an artifact there in photograph E by the tape measure. And H shows Jiaozhou Wu Yi proudly standing beside it. You can see it extracted in the lower photographs as a core. And what's nice is that they take then the paleomagnetic sample immediately beside it. So there's no question of being unable to correlate the section to the artifact because they're both together. And also as a check on the original context. But if it's in slope wash, the paleomagnetic sample will show a random signal. But if it is in context, it will show a normal or a reverse polarity. And that happens in every single case that I'm showing you this morning. So we know it's in its original context. So that is soil 24, I think, at 1.71 to 1.73 million years in age. So we're now slightly older than the Nihuan Basin at 1.66 million. And I'll show you this one at soil 27, which is 2.01 to 2.1 million years in age. I take some credit for this because the construction of the road basically cut a section across the entire hillside. So when you cross the road and stand by that section, you're actually inside already the Loess Plateau. So you can see the road and the section. You can see where I've made a mess of it by cleaning it up. And whilst waiting for the vehicle, being compulsive about these sorts of things, I started to clean the section, and that's how that set of discoveries resulted. You can see in photograph E at the bottom, thin layer of slope wash on top. There's a very thin crust on the vertical part of that section from the previous monsoon. Once you get rid of that, you're into original loess or paleosol. And so to start that sequence, the routine is as you clean up that section, I felt a piece of stone against the trowel. That's an A. So you gradually expose it, photograph, gradually expose where the finger is pointing. Then it starts to emerge like releasing a sculpture from a block of limestone, shown in C. Keep photographing and photograph each other, photographing it in D. Then it gradually emerges, so you can see now with G, you've got a large core with 3 parallel flakes off in front. And it finally emerges in H and I, so it's a large core, elongated, which has been turned over, broken in half, and then 3 flakes knocked off the front. That was the first item from soil 27. And the next one came out next door to it. The same sequence, you find a tip of a piece of stone, gradually expose it, label it so there's no confusion, extract it. In F, it's a very nice quartzite flake. There's a platform at the top, flakes on both sides, still very sharp. And the paleomagnetic sample's taken immediately beside it. And the same happens again. So I'm showing you these because they are over 2 million years old. The core extracted the same way. And then Chinese colleagues followed that up by doing an excavation nearby. 45-degree slope, which is about the gentlest you can find in that area, cutting into the hillside. artifacts emerge, those pieces of paper at the back of the trench, so you're not near the surface, you're near, way into the hillside. You can see there the pedestals show artifacts, and a paleomagnetic trench dug immediately beside it, and another 100-odd samples taken from that little trench, and also above. And what is very nice here is that those artifacts are sandwiched between the base of the Olduvai event at 1.95 million and the reunion event at 2.13. So the artifacts shown and by those little arrows on the left-hand side are neatly sandwiched between 1.95 and 2.13 million. Clearly in context, and clearly artifacts. So to show you the earliest material, it's fresh, that's a shattered core. Bottom right, much sharper, better shaped piece. Two nice little, probably scrapers, quartzite from the same trench. Below one flake on both sides. Some fauna casually associated with the artifacts. I'm not drawing any causal association here, but there is fauna, and there is better preserved fauna in other localities, so we'll be maybe looking for those later. And that's the total we have from 2.1 to 1.95 million. At the top, those pieces from the roadside section, that large core on the right-hand side, and the rest of it comes from either soil 28 or the excavation. And you can see there the flaking angles and directions on the right-hand side. We have two hammerstones showing percussion damage, shown there. And the nice thing with that sequence, it's a sequence from 2.1 up to where we stopped working at 1.1 million. We could go to the top, but we didn't there. And it shows repeated occupation, not continuous, but I think repeated occupation, mainly in warm periods. There are 11 Paleosol contexts and only 5 Loess contexts. So I think they're moving to and from the Loess Plateau when it's available and suitable for occupation. To tie in briefly to what Sonia was saying yesterday, raw material type is quartzite to some extent, 95%, 5% quartz. Yes, we have conchoidal fractures. We looked out for those in particular. Repeated patterns, yes, multiple flaking, multiple directions of flaking. I brought all that experience from previous work in Pakistan. Context is absolutely essential. None of this material was found on the surface. We had to be very careful about that. It's all in original context, and that can be demonstrated from the paleomagnetic samples. The technology, yes, it's core reduction. We have 3 types. Core rotation, to some extent. Percussion marks, yes, the hammerstones. Multi-purpose, I agree there with Sonia. There's a spectrum from usage from core, percussor to anvil, and back again. The main product will be flakes. And in terms of technique, some bipolar, not much. Very little block on block, or what Sonia called passive. Most of it's freehand, which is not unexpected. As for the future, 2 directions. One is to search below soil 28. In other words, to go back to soil 33 at 2.5 million. It's worth a shot. It'll take some time to demonstrate, but I would expect to find artifacts going back in the Loess Plateau to 2.5 million to the base of section. And hopefully, if we find artifacts on a slope less than 30 degrees, it opens up a possibility then for excavation, which we obviously cannot do when the sections are almost vertical. So with that in mind, thank you.